Okay, welcome. Today what we're going to do is we're going to be checking out our textbooks today. So we're going to get a physical copy. We'll get the online version tomorrow. Today is physical copy only. I'm going to explain that. I'm going to put the schedule up on the board. You guys are period 6. So currently we are here. We're out here at 1:13. Gives you an idea. You can get a clock watcher. There you go. It's 1:13. So, all right. But what we're going to do is I'm going to hand out the textbooks. I'm going to ask you for the number that's in them after a little while, so you don't have to tell me right away. So, but yeah, so the numbers will be inside the front cover. So keep that in mind. All right, so I'm going to hand them out here in a second. I'll leave that on the board just for right now. All right, here we go. Back. Once the book cover already on there. So you want a book cover on it already? Don't care. You do? Alright, perfect. Here's your assignment here to get it done. Perfect. Alright. Back if you don't want it. How many books? How many more do we need? And if you don't want that book cover, you can tear it out too. Give them out of thing. I think that's one for everyone, don't we? Alright, did anyone not get a book? Perfect. Okay, now, first assignment of the year, what is it?
Book cover.
Book cover. 2 people in here already have done. Perfect, good for you. So, it's due by Thursday when you walk in. So, don't be that person that walks in and goes, oh, I'm going to cover it right now. You just lost all your points. So, it's all or nothing. There's no making up that assignment. Right out of breath. That's terrible. All right, now, here's what we're doing today. I want to get your numbers from those textbooks. In fact, I'm going to stop the camera. I'm going to say names and I want to hear your name. Okay, so the activity we're going to do is called a 5-minute challenge. We do these kind of throughout the year, so don't feel like it's every day. It's just kind of like one of those things we introduce a new topic. Okay, so a 5-minute challenge, let me explain what it is. It is a challenge that is introducing a topic, but it's not in the grade book. It's just one of those things we're just doing to like get our brains flowing, to get you moving around the room, so you're not just stuck sitting the whole time. Okay, you can talk to some neighbors and get some lively conversations going. So, the idea is that we do it throughout the year. They will seem random, but there is an actual purpose to it, so they are purposeful. But it's to introduce a topic and get it so that it connects with some real-world connection, some topic in the real world, so you can actually see how we use geometry. But it's to challenge you enough where you really have to like use a group effort to figure it out, right? So you might have to use tools, like geometry tools, like a protractor, a ruler. I have rulers in the back. They're over by the, the flag back there. I have protractors and calculators and compasses. Those will be in the rooms when we eventually get to those types of things. So there's things that you will have to probably use to get through these challenges. The hardest part about the challenge is I can't help. I'm not going to assist you. Your group has to try to figure it out, or the class has to try to figure it out within 5 minutes. Does that make sense? It's kind of fun to introduce a topic and get you moving. Okay, we get the idea? So here's our challenge today, to introduce our topic today. So, 5-minute challenge is to find a location on the board, or location I should say, just a location in general, that fits the following description. Number 1, it's equidistant from the tree and the flagpole. Now this can be in the room, right? It's in this room, we're not outside. So in the room. So equidistant from the tree and the flag, those are my tree and flag, And it is exactly 2 feet from my little bird bath fountain. 2 feet from the fountain, equidistant from the tree and the flag. Now, what your group, because you're going to break up into groups, you can go into any group you want. No more than 4 people in your groups. You can move around, you can sit next to them, you can stand next to them. I don't really care where you go. You're going to have some lively conversations. But once you find this location that meets both of these stipulations, you're gonna try to mark that visually. You're gonna try to mark that visually with, a magnet. So I got a bunch of magnets here. You can just put them anywhere you want. You can have a volunteer do it, etc., etc., etc. So I have a bunch of different things. Get the idea? So get up and move. Find your groups. You can go stand. You can kind of sit together. You can go wherever you want. You can grab any tools you want. But equidistant from the tree and the flag, 2 feet from the fountain. Okay, no more than 4 people.
I don't know this.
Yeah.
Are you measuring that day? I'm measuring millimeters. So. Yeah, let's just 2 feet right there. Going the wrong way. Look at what
Guys, we're never gonna figure this out.
Anywhere.
It's the same distance between the two, it doesn't hurt, it's not necessarily.
It's right there. Somewhere in wherever 2 feet measures. Right here.
Really?
No, it's like right here.
It's right there. Well,
Someone marked it.
it's okay, you know, it takes 7 years.
Is what
Go up.
from the tree as could get up. That's exactly right here. What?
Stuck in my head. Wait. Okay.
Yeah, it might be different.
No, go from the.
I'll just work it together.
Okay, you do a measure from the tree.
It's right here.
I'm just doing what they
Yeah, it's tree the flex.
Oh, you figured
And
it
go
out.
up from the.
I'm pointing to it, Brayden. I'm not on the spot. I'm pointing to it. Yeah.
It's basically
What?
I know.
It's from the parents' gift.
Is it from the paper or the flag? The actual flag?
No, it's not.
Has to be exactly the same.
It is water points on that desk.
That's a whole different.
It's touching the fountain.
Maybe there's a
What? Right there.
If you think it's a different spot, you can always put your dots, because I have multiple magnets up there, if you want to put up a different one, if you're not agreeing with a certain group. Don't feel like it has to be just one dot. You can have multiple groups with different dots.
Right, just move this magnet.
Say it's 30 and a half.
She does magnet.
Sam, you know you should agree. Yep. I should try to get it. You have at least shit to it. Sam, you're gonna agree on this.
That's way closer. That's way farther.
Oh, that's what it is.
That's right. Man, I'm trying to
It's not funny.
Sam, how many minutes do you have? Check it one more time, Sam. I can't.
Well, not right now.
Got about 2 minutes left. If your group is satisfied with their dot, you can go sit.
Wait, no, sit down, sit down. If you're satisfied with the dot,
You literally have a minute.
if you're satisfied, you don't Anna, don't satisfied with the dot. I didn't do anything but give you the ruler.
Alright. That's the flag. Right there.
Oh, wait, you suck.
Put that back up there, Kat. That was their dot. What are you doing? Go grab your own.
Oh, they put 2 of them.
Yeah, that was my guess. Go back.
Oh, your guess is
You only have
probably
one guess.
Nuh-uh. If you listen, you can have two.
I'm getting this.
Oh.
Yes, I have as many magnets as you guys
So it
know.
has to be thinking
Minus one.
Can you just hurt my Sophie, yours is different.
Dash, I'm throwing on that.
I don't.
Oh.
Nice catch.
So that's.
I think
So then we just have to
I think that one.
my chair is like an old Ricky chair.
Sorry.
You have 30 seconds.
Would Lily and Mary please come to the office?
I thought her name was Eric.
Just gotta make sure until she didn't start when Holly was Holly and Josie was Josie.
She haven't got 15 seconds.
Because Holly didn't and Josie didn't get their name.
Josie, everyone call her Josie.
She did get it.
Yeah.
Holly's.
Lily get
Oh.
a name?
I don't think so. I think
No,
your
wasn't
name
it
is maybe a
Alex?
try.
I think we're
Then on the birth certificate.
Okay, all right, let's discuss. Okay.
And the gender.
Yeah, I had the camera going because I want to see kind of your rational thoughts about it. It's not a big deal. So, here's the thing. We got a bunch of dots up there. Okay, some of you are getting very precise in the measurements and stuff, which is great. So, let's talk about this. What does equidistant mean? Yeah, it's literally two words. Equal and distance crammed together. And so it's equidistant. It's a new vocabulary. It's actually one of the vocabularies in our chapter that we have to learn. Okay, so you guys already kind of know what that means. It's got to be from the tree and the flag. So that means it's got to be somewhere in between them. Okay? Now, it's got to be 2 feet from the fountain. That was the tricky part a lot of people were getting caught up on. They were trying to measure exactly 2 feet, which is the tough part, because you do have to have a ruler, so you guys want to grab those, that's fine. Now, visually marked it with a magnet. A lot of you had volunteers up here and you put multiple magnets there, which is fine, because you had some different guesses. I've noticed everyone kind of went in roughly the same area, okay? Because your guys were trying to measure and be somewhat exact. Is there anyone that did not get to place one that thought it was in a different location than kind of the rough general area where we were? Is there any like majorly like different thoughts about where the spot is? Like really out there? Okay, because I had one group that they tried to put their magnet, they tried to use tape, and they tried to put their magnet like over here. Which, because I know it doesn't have metal, but they're trying to put it up here, because they're 2 feet from the fountain. And they thought they could be equidistant from both of those, which was clever. But what if I told you your dots are wrong? And it's not the one that I was talking about. Like this person up here was also wrong.
I moved it.
So now what? Now we're back to the drawing board again. What are we missing?
That is a good question.
Huh? First of all, hold your finger. Yeah, okay. What if the spot was the tip of her finger? 2 feet from the fountain. Now, I'm exaggerating, because it's more than 2 feet, but what if the spot was like here? It's 2 feet from the fountain, but equidistant from both of them. Floating in space. That's the spot I wanted. Because I kind of led you, like, oh, you could use a magnet, use a volunteer, etc. The volunteer was what I was hoping for. Have somebody just stand there. It's here, floating. That's the hard spot of our geometry. It's not algebra 1 anymore. Algebra 1, I'm solving for x, solving for y. I know the answer's 2, right? You did all this work. Geometry gets messy. Because there's an actual infinite number of answers you could have picked. Not just this one. Not just that one. Not just this one floating, the one I was kind of looking for. Imagine there's a beach ball that is exactly a radial distance of 2 feet. So the fountain's the middle of the beach ball, like the core of it. And it's 2 feet around. And it's surrounding this fountain. And you just want to be equidistant from both of them on the beach ball. There's an infinite number of dots you can pick on that beach ball. That's the idea. That's where geometry is like, if you think about it, it's like, I want you to think outside the box a little bit. It's a hard thing because some people cannot visualize in 3 space. They can't even think about that. Because they're so stuck to like linear, is the way I led you with questioning, but you're so stuck to like, I want to be on this flat surface, but you could be off of it. That's where geometry gets difficult because we have to train you to think outside that box completely to think about topics. Because there's more than one right answer sometimes. Does that make sense now? Alright, it's kind of a challenge. It's to wake your brain up a little bit like, hey, this is what I want you to think about now. Alright, let's get rid of this. Okay. So, we're gonna do a couple things. I want to go through your book. So if you want to open up your textbook, go to the Roman numeral XI. That's Roman numeral 11 in your book for page number. All right, so you're on XI, correct? All right, so on XI, do you see the top of the page? It says, it's in a green box. Sorry if you're colorblind, it's a green box to me. It says Chapter 0, Preparing for Geometry. Okay, so this chapter we're going to skip. We're skipping Chapter 0. We're not preparing for geometry. You're in geometry. So skip that, flip the page. So we're going to X11. So, or XII, which is 11, sorry. So we're in Chapter 1, Tools for Geometry. So if you look, this is the table of contents. I want you to get used to the table of contents because in this class, we'll jump around from chapter to chapter a lot, section to section. Some days I'll be in Chapter 1. The next day you walk in, we're Chapter 9. We're back to Chapter 2, like we'll bounce. Because I want to keep it linear, like I want to keep it progressing so it makes sense to you, so we just keep kind of build on the topics. So we'll be outside outside that normal like pattern. So now, we're going to be starting in section 1.1, because we have to start with the tools. We have to start with basic vocab terms. So now, when I write it on the board, I always put an outline up here what we're doing that day. Today I didn't, but here's what we're doing. So, section 1.1. So, this little symbol, it means subsection. It's literally two S's connected to each other. Subsection. This is the chapter we're in. And this is the section we're in. So if you're ever wondering, why do I have that weird symbol on the board and two numbers after it? Chapter, section, so you know when we're on. So that'll be usually up here. So what's the title of our section 1.1? Points, lines, and planes, if you can see it. That's what we're talking about today and tomorrow. So that keeps you an idea, gives you a focus. What page does section 1.1 start on? Page 5, right? Not P5, but 5. As you can tell, when we get to section 1.7, what page number is that? 67? That's a lot of pages for one chapter. Lots of pages. This is a big, hardy book. This is pretty thick. So keep that in mind. There's a lot of pages, so use the table of contents, especially when we're in a different chapter. You don't always have to ask Ward what page you want. Go to the table of contents, go find it. Okay? All right, go to page 5, like the number 5, not P5, but just 5. Go find it. Okay, at the top it should have a blue bar that says 1-1, points, lines, and planes, correct? Okay, everyone's there, everyone's at the right spot. Points, lines, and planes at the top. It's at the number 5. Okay, now, the reason why I bring this up, most people that struggle in math, it comes down to, can you even read the book? Do you know how to decipher it? Because geometry is very different than algebra. You've already experienced it's different. Like, we're doing a lot of vocab, we're doing conceptual stuff, like visual stuff. We're not doing so much solving for X every day. It might be just vocab words. There's a lot of vocab on my tests, so you have to be used to that. If you look at this first page, look at all those words that are highlighted in yellow. That was the first page alone. There's, what, 6, 7 words there? 5, 6? That's a lot. There's like 40 vocab words in the first chapter alone. We're not going to have all 40 on a chapter test. That's stupid. No one can memorize 40 words. Maybe have 10 big words that you should know. But where do you find them? You find them in the chapter. You should be constantly skimming through the chapter, the section we're in, to pick up those words. And it's your responsibility to actually open your book. I know it's crazy. You got to actually look at it every now and then, see what vocab words we're supposed to be learning. But to read them. Now, some people, like, they really struggle like how to decipher the definition, because some of those words are just in the middle of a paragraph. How do you decipher what the definition is? You can go to the back. Your back of your book actually has a dictionary. So you can go all the way to the back, you can find those words in the dictionary, and it actually just tells you exactly what the definition is. I usually will always go through the board, put the definitions up here. I paraphrase some books, I pick similar wording, what the book has for all those definitions. You do need to know both, because that could be on the test. But it's one of those things like some people just struggle, like, oh my gosh, I didn't realize we had to know vocab. Yeah, it's a part of geometry. You have to know the words, the terminology we use. If you look at the page, there's that big gray box there that says key concepts, understanding terms, or whatever it is. There's lots of vocabs. They have really nice, pretty pictures in there. Turn the page, go to page 6 and 7. Okay? Green boxes are examples. They have study tips off to the side in the margins that are marked in orange, right? Study tips. So it's one of those things like you just got to get used to like how to decipher the book. Key concepts, those study tips are actually somewhat important. I don't know why they put them in little bubbles off to the side. Some of those are equally important. If you look at page 7, look at that example at the bottom, that pentagonal prism, a pentagonal pyramid thing on page 7, that bottom example. The hardest part for some people in geometry, can you even see that that thing is in 3 dimensions? It's like 3-dimensional. Some people cannot see that. They can't even wrap their head around it. That has like multiple sides to it, multiple facets. Like some people can't visualize, like you could turn that picture and see the back of it. Dashed lines are in the background. That's how you have to like visualize that. If you look at the line right next to it that's poking through the paper, what is that line? LM? It's doing this. It's poking through the paper. How do you know that? It's using a dashed line. It's poking through it, not laying on top of it. So that's stuff like you have to get used to when you go out through the book. Some people can't do that. I had a couple students from previous years. They cannot see things in 3D. Like it just, their brain cannot wrap around it. So they only see it in 2D. So they just think it's like 2 pieces of paper stacked on top of each other. They can't see that it's supposed to be 3-dimensional. Like I always had to give them like a visual model. So they're like, oh yeah, and they can pick the things they need from that model. So just keep that in mind, keep me informed if you're really struggling with that. Because like that picture can be just a brain breaker for some people. Okay? Alright, turn the page. Go to page 8 and 9. 8 and 9, this is where the homework starts. Look at those, all those problems. You're on the top of page 8. It says checking for understanding. Check your understanding. There's a bunch of problems below it. There's even a blue bar at the bottom on page 8 that says practice and problem solving. They have more homework and then it spills over. When do the homework problems actually end? Keep flipping pages. When does the homework problems actually end? Page 12? Page 12 or 13-ish? How many problems are in that first section? 85 questions. Holy moly, that's a lot. I'm not going to assign all 85, that's ridiculous. Usually what I do is I kind of pick problems here and there. So it's like when you see your geometry homework over there, it'll be like page 8, problem number 2, number 14, number 50, number 62, number 85. Like, I'll just pick kind of some random problems I want you to do because I want you to have more practice with them. Sometimes I go 1 through 7, but you have to be paying attention like what section am I on? Like is it section 1.1? Is it section 1.2? Is it in the practice problems? Is it in the checking for understanding? Like, because sometimes they go 1 through 12 and then they start over 1 through 12. So be careful like what assignments I assign. If you go to page 13, they extended the section. So there's something else they wanted you to know from section 1.1. They didn't start section 1.2, they extended it a little bit further. They applied things to 3D now. Turn the page, go to 14. Now that's the next section. You see how the sections always start with that blue bar? Or whatever color you're seeing if you're colorblind, sorry. So I want you to get used to how the book is laid out. It's very similar every section, every chapter you go to, it's all the same. They have very nice pictures, it's a very nice book, it's almost 2 years old, so it's like, it's new. So like don't damage it, it's kind of nice. Especially when you see the online version, it looks just like this. You just click and it just kind of flips pages, it looks nice. So get used to that. It's one of those things like, just seeing how somebody can read through that book makes it so much easier to like, being able to like understand it. So you're not like overwhelmed by what you're looking at. Okay, questions at all about the layout? Okay, let's go back to page 5. Go back to that. So I'm going back to 1.1. Okay, what does it say at the very top again? Points, lines, and planes. All right, close your book. We don't need it. I just want to get you that topic. This is our topic for today, points, lines, and planes. So let's write that down. Let's go back to here. So, points, lines, and planes. Okay, these are our vocab words that we have to talk about these next 2 days here, so you get some better understanding of it. Because this is the intro. Like all this stuff, These three topics make everything in geometry. Those three words make every shape you can think of and every type of math by just putting these three things together, which is really kind of odd when you think about it. So let's start with the word point. Start with that. Let's go through the definition of it here. So a point is a location in space. So if you have your notes, you might want to write this down. Again, if you have your notes, take it out. I don't have options. You got to take notes in here. We covered too many vocab words for you not to write it down. So a point is a location in space labeled with a capital letter. Okay, that was what I was asking for earlier. When we did that little activity with this whole flag and tree and fountain, I was asking for that location. Find the location. Find the exact point that meets this stipulation, right? A point is non-measurable. Non-measurable means we don't measure it. You know, that it doesn't matter the thickness of the dot. It's just that location, that specific spot. Okay? So when you see a point, it's usually labeled a dot of any particular size. They usually have a capital letter sitting next to it. So in the book, like if we're doing a test or homework, and you know they're asking for, like maybe there's a bunch of points on your paper and they're asking for a specific one, that's what you're looking for, that dot, that capital letter next to it. Now when you say it out loud, this is what you say. You say point A. That's how you say it, right? That's actually how you write it as well. This is how you draw it. This is the visual representation of it. But this is how you'd write it if you're answering like a test or a homework question. Like find that location that meets that stipulation from the fountain and the tree. Well, point A. So boom, that's the one. That's how you write it down. I'm very specific. You can't just write A. You have to write point A. That's the part that most people get wrong on my test and homework on the first one. Is that they're so worked up about what the answer is, they forget notation, the exact way you're supposed to answer it. I'm really particular on how you answer questions. That's something you'll get used to very quickly. Especially when you start doing homework and you start marking things, you gotta go fix it. Okay, questions? Questions on notation. This is what it looks like. This is how you're supposed to write. Okay, now. There's a vocab word I just wrote there a little bit ago, but I haven't labeled yet. Space. I know it's not up here for my main three. Space is a word I use in there, a location in space. Not the final frontier, this isn't Star Trek. Space is the set of all points. It's a set of all points. There's, when I was talking about this example over here earlier, there was an infinite number of points we could have hit that would meet that stipulation. So it's the set of all of them is space, three-dimensional. To define space, the definition set of all points, but how you actually visualize it, it's four non-coplanar points. Yeah. Every time we get a new vocab word, it's just like a rabbit hole. We just get more words and more words and more words as we go. That's how we actually define space. It's a set of all points, but it's made from four non-coplanar. Now let's talk about that word non-coplanar. That's probably a brand new word to you. You probably have never heard that word before. What is a plane? A plane. Say it out loud. I think you know. Plane? Not an airplane, but a geometrical plane. Flat surface. You nailed it, right? It's a flat surface, right? So like a marker board, a piece of paper, that could be a plane. But I want to be non-coplanar. It means I do not want to be on the same flat surface as you. Right? Non-coplanar. So if you had your piece of paper, you had a couple dots on it. I want to have a couple dots that are not on the same flat surface. Maybe my marker board versus your paper. That's non-coplanar. Why there needs to be four is four now establishes like length, width, depth, height, that type of thing. You need 4 to actually make space in a room. So 4 non-coplanar points, not on the same flat surface. Okay, questions with those 3 words so far? Okay, I'm gonna write the last word up there, and we probably won't get to like the visuals and drawings of it until tomorrow. But the last word I want you to write down is the word plane. I know Cash already said it, you actually pretty much nailed the definition of it, but a plane is a limitless flat surface. It's a limitless flat surface. Now, how it's made is using 3 non-collinear points. As I said, every vocab word just keeps getting deeper and deeper. So a plane is a flat surface, limitless. So imagine if you have really good imagination. Imagine you look at your piece of paper in front of you, and then the walls extend further, up, down, right, and left. They just keep going, and it keeps growing bigger and bigger piece of paper, right? A limitless flat surface, it's made from 3 non-collinear points. That's the stuff we're gonna start with tomorrow, what that means. Make sense? What's our first assignment of the week? Book cover. Get it on there before Thursday. I'll remind you every day of that.